Hello, my dear friends. Welcome back. So, as promised yesterday, I had promised you that we will be going live. We'll be trying to go live from today. So, yeah, it was somehow possible. So, but of course, a certain part of the board is not visible here. So, I'll try to limit it within the visible region only. But we will begin from exercise. Continue, not begin. Continue from exercise 7.4. 7.4 because last video was about exercise 7.3. So I believe that you have all the formulas. This part is not visible, but I am sure that you still have your textbook with you. So we can just go through the textbook, take out your textbooks, notebooks, those who are practicing, those who have come here to learn. Because this channel is just about learning, so I'm sure that you have come to learn. So in the last videos and all, we started with the different methods of integration. The first one was substitution, if you remember, where we use trigonometric ratios, trigonometric identities, and then we integrate. And this is the second method where we discuss about some integrations of some particular functions. We also call them special integrals. Special integrals. There are actually 9. So in this exercise 7.4, we will first learn with the first 6 particular integrals, special integrals. And then I think in 7.6 we will be coming across 3 more special integrals. So these are the formulas. We will not be deriving, especially in our MBSc board, we generally do not derive the formulas. The theorems are generally not used. We can, maybe some other day we'll practice deriving the formulas also. So we will learn a little bit of integration with this second type, that is second methods of integration, because we have this special integration by substitution. That was the first method, if you remember. Then we have the second, that is integration of some special functions, some particular functions. And then third, of course, we have integration by partial fraction. That is also a very beautiful method. This is also a very beautiful method. But of course, yes, you have to get accustomed with the formulas. But try not to memorize the formulas, because that's really going to be a huge task for you. Trying to memorize the formulas and all. So try not to memorize the formulas. It will come automatically. Okay, it will come to you automatically. You just Arun, hi. It will just, and Jati also, hi, hello, good evening, good night. Yeah, good evening, I would say, right? You practice well, you do enough practice, then the formulas will automatically come to you. Okay, so do not worry about remembering the formulas. You practice enough, so that should be, the formulas, as I say, will come automatically to you. So don't worry about formulas. You might say that, yes, sir, the formula is like, how are we supposed to remember? You will remember, of course, definitely with practice. Hello everyone, of course, most of you are coming, joining the classes. It's good to see, it's very encouraging for me also. Because if there are students who are always eager and ready to learn, then it's very positive. Okay, it's very encouraging, because the effort that we put in, it's not gone to waste. So we as teachers, we are also trying our level best to give you as much as possible. And it's good to see that there are many students who are like eager and trying to learn and cooperate. So it's give and take. So it's good to see. Thank you for being in this small family of ours where we are trying to learn. So I hope you've got the formulas ready with you. Actually, live classes, I am going for it because that is going to save me a lot of time. So that's why I prefer these live classes, because that way I'm able to save time also. Time is very precious. So yeah, definitely I'll record also. I'll make more videos also on different topics. But let us try and see whether this works out or not. Because there's no harm in trying new things, isn't it? Because when we start exploring, when we start learning. So without exploring, we cannot learn new things. So this is an exploration time, so we are exploring, trying different mediums, platforms to learn. So let's try this one also. Alright, so I believe that you have all of your books and all, so I think chatting should be enough. Later on we can do that. Take out your books, pen, paper. I hope all of you are sitting on your table and then you've placed your mobile at the right place. Let's begin with the exercise, that is exercise 7.4. Let's begin with the first question. So I believe all of you have your formula sheet with you. Please do note it down, because see, remember, there are times when some people tell you, like when you do mathematics, try to remember the formulas, and then when you start practicing, do not keep the formulas near you, try to memorize it. No, that's wrong. Okay, completely wrong. Don't do that. Like, feel free to keep the formula sheet in front of your table when where you're studying. Don't try to fool yourself. No, just keep it in front of you. Keep it there as long as you really do not get accustomed to it. There's no harm. It's not copying, or it's not. That's the way we learn. So just keep it in front of your table, and then every now and then, whenever you have some doubts, and just go to the formula. That's really going to help you with it. There will be better interlinking with your brain. Okay, so let's begin. Exercise 7.4. 7.4, the first question. Integration of 3x squared. 3x squared by x power 6 plus 1 with respect to x. Integration of 3x squared. So we had one model, one special integral. What was that? Integration of dx by x squared plus a squared. X squared by a squared, that was tan inverse of x by a plus 1 by a into tan inverse of x by a plus c. So here we will be using this particular formula, but it's not in the proper form. So remember last exercise, that's why I told you for this year NBSc syllabus, from the NBSc syllabus, that previous exercise has been reduced. But I still made a video on that, because I told you that we are going to need this integration by trigonometric substitutions, and especially integration by substitutions and all. So please go through that exercise also properly, okay? So we will be using substitution here first to convert that in this format. So what can we do here? See, the hint will be already given to you here, not 3x squared. 3x squared, we have x power 6. So what maybe we can do is something like 3x squared x cube whole square plus 1, because of course the concept of differentiation is very important. Okay, the knowledge of differentiation is very important in integration. I've been continuously telling you that from day one, because the concept of differentiation only will help you solve integration. Otherwise, how will I know what to substitute? No? So with this, what I can do now is make a small substitution. Let x cube be equal to t. So since we have already done that substitution part, you will not go back and discuss that again. So let x cube be t. So what happens is, if we differentiate both sides, we have 3x squared with respect to x as t. So this term can be easily substituted. This will be easily t squared. So we can now just make that substitution. I'll write over here. So then in that case, I will be 3x squared with respect to x dx, that becomes dt, by x cube. X cube we have substituted to be t, then it's squared, plus 1. So now you can see that this comes of this format, where dx by x squared plus a squared, where a is 1. So 1 I can write as 1 squared also, no problem with that. So that will be 1 by a. What is the value of a here? 1. 1 by a tan inverse x. What is the value of the variable here? X is t upon a plus c. So that is tan inverse of t. So t we have substituted as x cubed. So that will be simple. Tan inverse x cubed plus c. Now, why are these called special integrals? Because this formula helps us to solve certain complicated functions which may not be very easy to integrate in simple ways. So that's why these methods are very important, very beautiful methods are there. And in this exercise again, there is one very beautiful method which we'll be learning in the second part only. I hope you're done, right? Okay. Let's go to the second question. We'll try to solve as many as possible today. Second question. Second question is, okay, note it down. Integral of 1 by root over of, so we'll be needing that second set of the special integrals here. 1 plus 4x squared with respect to x. 1 plus 4x squared with respect to x. So now here, of course, the best way to do is follow the model. Follow the model that is given to us. So for this, the model that is given to us, the formula is integral of root over of x squared plus a squared. So what was that? Integral of, you can check out your book. What was the formula for that? It is log of x plus root over of x squared plus a squared plus c. Now, see, x is actually, just to avoid any careless mistakes, I mean, okay. So x is like free of coefficients, x squared, that's the model, so we will prefer doing using that model. As I always say, it can be done in many methods, okay, many methods, many styles, different teachers, different styles, as long as it's mathematically correct, really doesn't matter. So choose your own style, choose your own, you choose which one is best for you. What I mean to tell you is that choose the best method which is easiest for you, okay? Maybe not mine, maybe somebody else's method, no problem with that, as long as you're learning, that's it. So what I'll do is x square, this variable x, I will try to keep it free of the coefficients, so that can be done simple mathematics by taking 4 common, so that becomes 1 by 4 plus x squared. Now square root of 4, as we know, is 1 by, square root of 4 is 2, so I'll just take that out. Root over of 1 by 4 plus x squared. That is 1 by 4 also, we can write it as a squared, because x squared we already have, so we can convert it as a squared, because 1 by 4 can be written as 1 by 2 whole square. I'm trying to reduce the steps here. 1 by 2 whole square. Now that's all that we have here. So just apply the formula, that is what? Log of x. The value of x is x here, plus root over of x squared plus a squared, that is 1 by 2 whole square, plus the integration constant c. So you can simplify this. Simplification, of course, most of this solution part and all, I think I'll leave it to you so that we can just save some time so that the video doesn't go too long. So that will be 4, so 4x squared plus 1 divided by 4 plus c. Alright, so that will be, of course I'll just simplify this for you. That's going to be x plus root over of 4 x squared plus 1 upon 2, because square root of 4 will be 2, plus c. That again can be written as 1 by 2 log of 2x plus root over of 4x squared plus 1 divided by 2 plus c. Alright, so now if you wish to get the textbook answer, we have one formula from logarithm, that is log of m by n. What was that? Log of m minus log of n. Actually, I don't see any problem why you can't just leave the solution here also. Not a big deal with that, okay? But if you want to simplify it further, we will apply that. So that's going to be 1 by 2 log of this value, 2x plus root over of 4x squared plus 1 minus log of 2. I'm just writing it below here because there's less space, that's why. Alright, now log of this is m by n, so that will be log of m minus log of n. Alright, because of this logarithmic principle. So then if we just multiply, then it becomes log of 2x plus root over of 4x squared plus 1 minus 1 by 2 log 2. Of course, plus c. 1 by 2 log of 2 plus c. Now, 1 by 2 log of 2x plus root over of 4x squared plus 1. I'll just write here plus c. Okay, now you might be wondering, like, how is that possible? Where has this 1 by 2 minus 1 by 2 log 2 disappeared? See, what is this concept about? This is just about a constant value. Now 1 by 2 is constant, log 2 is a constant value. That means, like, I'll just give you here, there is 1 by 2, negative value, forget about that negative value, because constant means constant, negative or positive. Now 1 by 2 log 2 is a constant, constant, and c is also a constant. So this is a constant, this is a constant. So constant plus constant will give you what? Constant plus constant will give you constant. So that's why I just wrote that. So no need to explain all of these things. No, actually not needed. We can just write plus c also. I think that should be enough. Okay? I think that problem is clear now. Right? Because most of the students I've seen that they have this done, like, sir, I'm not getting the textbook answer because 1 by 2 log 2, what happened, where has it disappeared and all. No, it's simply a constant. So constant and constant, we just compile together, we just represent it in another constant again, c, but that's all. Okay? Alright? Fine. Let's go to the next question quickly. That's the third question, that is integral of dx by root over of 2 minus x whole square plus 1. I think that's the question, isn't it? Root over of 2x square, 2 minus x square plus 1. Alright? Okay. Now in substitution method, so here again we will be using the previous formula only, that is root over of x square plus a square. Just now we have used it. So in substitution method, if you remember, I had told you that you can directly substitute without writing all the procedures if you are just careful about the coefficient. For example, like integration of cos x with respect to x, we know that it is sine x plus c. I'm not writing that because c is not our concern here now at the moment. So I told you that if it is cos of 2x, all you can do is simply sine of 2x, divide that by the coefficient of the variable that you have with here, the variable here 2. So we'll just divide it by 2. That's what I told. So we can do that, but here of course in this question even that is also again not needed because it's something like x square plus a square, isn't it? But we have here 2 minus x square, but that can be taken care of. That is, what I'll do is, see, whole square really doesn't matter because whole square 2 minus x square or x minus 2 whole square, it's all the same. because of this whole square, x minus 2 whole square or 2 minus x square, that's all the same because it's not an odd exponent, it's a positive number, so that won't be a problem for you. So we can do that and then bus, oh yeah, you can just, and here once we do that there is no coefficient with x, 1, so without substitution we can just assume this to be x and then just use the formula. So what was the formula? Log of x. Now what is our x here? X minus 2 plus root over of x square plus a square plus the integration constant bus, and then of course that will just simplify if needed and you'll get the solution. If not, we can leave it there also, no problem with that. Okay, so fine then, let's go to question number 4. Question number 4 also almost similar. This integral of 1 by root over of 9 minus 25 x square, of course with respect to x. Integration of 9 minus 25 x square with respect to x, of course integral, we are integrating. So in question number 2, I told you that try to keep the variable free of the coefficient. And then in that case what we will do, again almost similar to that particular question, so that will be I will be trying to keep this variable free of the coefficient, so I'll take 25 common, so then I'll have 9 by 25 minus x square with respect to x. So that will be square root of 25, that is 5, that we can take it out. Dx, this will be root over of 9 by 25, that is 3 by 5 whole square minus x square. And then you know the formula for that, a square minus x square, root over of a square minus a square. So what was the formula? That cute small formula, what was that? It was of course 1 by 5 should remain. And then we had sine inverse of x by a. So that will be simply sine inverse of x. What is the value of x? X by a. A, it was 3 upon 5 plus c. Plus c. So that, if you wish to simplify, not simplify, write it in a better form, then that will be simply. I hope you're done with that. I'll just convert it here. So ultimately your solution will be, okay, I'll just write I equal to 1 by 5, sine inverse, 5 goes up, 5x by 3 plus c. Bus. It's a simple exercises. Practice well, हो जाएगा आराम से. Don't be tensed, okay? Exams are approaching, no need to be tense. You have plenty of time. Practice. Don't waste time thinking and planning too much. Too much of planning is also not good. Alright, let's go to number 5. Question number 5. Integral of, what do we have? 3x by 1 plus 2x power 4 with respect to x. With respect to x. Alright, so what can be done here? Same way. X square, we can write x, not a big deal with that. So think which one should be the best for you. So, okay, 3x, I'll just leave it. 1 plus, I'll try to keep the coefficient variable free of coefficient again, because substitution, I don't think, because if we substitute x power 4, then I think we'll have 4x cube. So we don't have a cube here. So substitution we will use, not now. Let's try to simplify this a little bit. After that we will use. So that will be 3 by 2. I'm taking this constant outside. 3 by 2 x by 1 by 2. Here now I will make a small arrangement. That is x power 4. I will write x square whole square. No problem, nothing. Because after that it's done. Problem is done. Because x square I will substitute. Now if you substitute x square as t, what is its derivative? 2x. We have here x. So that is also taken care of. Because if you substitute directly x power 4 in After substitution while differentiating, you end up getting 4x cubed. Now this x cube, from where are you going to bring this x cube? That's going to give you a problem. So you should be careful where to apply what. So after that, I'll just write here, that is let x squared equal to t. So then in that case, 2x with respect to x differentiating will be equal to t. So x with respect to dx will be dt upon 2. So we'll be doing this substitution. So then in that case, I will be 3 by 2 is already there. X with respect, x dx. This by substitution will be dt by 2. Then of course we have 1 by 2 plus x square, we have substituted as t, that will be t square. Of course, don't forget the bracket. Try to use as many steps as possible, especially in the beginning stage, okay, learning part. Later on, you can remove the steps, and then once you become experts, 1 by root 2 whole square plus t square. 1 by root 2 whole square plus t square. So what was the formula for this? 1 by x square plus a square formula. We'll use that. This is done, I guess, so I'll rub this off now. Okay. Those who are watching later, of course, you can just pause and just write it down. So what was the formula? Integral of dx by x square plus a square. The formula was 1 by a tan inverse x by a plus c. So that will be 3 by 4 into 1 by a. What is the value of a here? 1 by root 2. 1 upon root 2. Careful. Tan inverse x. Of course, our variable is t by a. Again, 1 by root 2 plus c. Now let's do a little bit of simplification, chalo. Because our solution is done, integration is already done, now just to arrange. So I'll just keep everything ready. That is 3 into root 2 by 4. Tan inverse root 2 into t. This t is outside the root, okay. Most of the times I've seen again students writing like root 2t, they will just write like this. T is outside of the root, not with the root, not with root 2. Now 3, root 2, 4. So that will be 2 root 2. Tan inverse root 2. The value of t was substituted as x square before. So root 2 into x square, root 2 into x square plus c. Alright, now let's again continue with question number 6. We'll try to solve as many as possible, but not for too long. Because after this we have a new method again, which is very, very interesting. That I'll do it in the second part. So let's just try to do the basic things today. So 6i equal to integral of x square. I think this one you can guess what to substitute, isn't it? Very simple. Again, as I said, differentiation concept is very important. So now here x square, you see x square we have. So what different derivative can give you x square? I think you can guess. That is, 1 minus x. 6 I can write as x cube whole square. No problem, isn't it? 3 2s are 6. Because derivative of x cube is what? 3x square. Forget about this constant 3. We can get that from somewhere here or the other. No problem with that. It's with the variable and its exponent, power and all. That's our main concern. Once that is done, I'll do the substitution. That is that x cube be equal to t. So now differentiating, that will be 3x square dx dt. So x square dx will be also substituted as dt by 3. So I'll just continue here. So I will become, what is this value? X square dx dt upon 3. 1 minus x cube I used as t, then we have square, so that will be 1 minus t square. So that will be 3 I will take out, dt by 1 square minus t square. So check out the formula for a square minus x square, a square minus x square. Okay, this formula I think we haven't used, so now we will use the second formula. What was that? We have one formula again, special integral. What was that? Dx by a square minus x square. So what was the theorem for that? Dx by a square minus x square, that was 1 by twice a log of 1 by twice a log of a plus x, a minus x. It will be good if instead of, for searching for formulas by flipping your pages, textbook and all, it will be good if you can maintain a small booklet or a paper which maybe paste it in your room just in front of your table, so that it will be always in front of you, so that way you will have good memory retention also. Whenever you see that, you will at least go through it once, and that way you can improve. You will get accustomed with the particular formula also. Okay, so that also helps. So that will be 1 by 3. Let's use 1 by into 1 by 2a. 2a value is 1 here. Log of a. 1. A is 1 here. Isn't it? This one. This is just a formula that I've written. Okay. A square minus x square. The value of a is 1, x is t for this particular problem. A plus x, a minus x plus c. Time to substitute. 1 by 3 to 1, 3 to the 6. Log of 1 plus t. What did we substitute there? T value I think we used as x cube. 1 plus x cube upon 1 minus x cube plus c. Plus c. So that's the solution to that. Alright. Okay then, so let's not make it very boring by extending the video for more than 40-50 minutes. Slowly we will begin. So I think we'll wind up here for today. Thank you so much, all of you who have joined and at least learned something. I'm very happy that hopefully I guess some of you have learned something. So tomorrow again we will try to meet again, continue with the classes. So I think we'll try to finish this exercise in maybe around about 3 parts. Yeah, maybe in around about 3 parts we'll try to finish. So this is the first part. Tomorrow's again will be more interesting because we will be learning some more, the same exercise, new ways of solving and using this special integrals. Okay, yeah, thank you also, all those who have been here. Thank you so much. So alright then, I'll see you tomorrow. Bye bye, take care, study well. Okay, study well.